How did we get here? Big questions about who we are and how we got to be that way are at the core of our nature. We've developed technology to see amazingly far across space and also time. Light moves through space, just like we do, only much faster. It takes time to get somewhere. So, viewing the light of distant stars and galaxies is like looking into the past. It took time for the light to reach us. Yet, after all our years of exploring, to better understand ourselves and our origins, there is still so much to know. Our story stretches back more than 13 billion years, not long after the expansion of time and space first began. At some unknown time, the building blocks of life were forged in the heart of the first stars. But much of the early universe remains a mystery. There are theories about how gravity first brought stars, gas, and dark matter together to form galaxies. But that time period has never been observed. Detecting light from the first galaxies to form has been a challenge for even the most powerful telescopes. As the light early galaxies emitted traveled through space, that space itself was expanding, stretching the light to longer infrared wavelengths. Past telescopes have detected infrared light, but the faint light of the very first galaxies has remained out of reach. Until now. The James Webb Space Telescope is specially designed to detect the first galaxies. Webb's large mirror and sensitive instruments will enable it to collect more infrared light than we've ever seen, allowing the first galaxies to emerge into view. With Webb, we can begin filling in some of the blank pages at the beginning of the universe's story. When did the first galaxies form? How massive were they? What types of stars and elements did they contain? The universe's story is our story, and with Webb, we can finally explore these questions, as well as uncover new ones we haven't even thought to ask.
Newborn stars are found within brilliant, colorful nebulae. However, star formation begins in dark, dense clouds. Within one vast dark cloud, gravity collapses thousands of individual dense clumps. The core of a massive dense clump will compress and heat until it forms a protostar. A protostar grows as a disk of gas and dust accretes onto it, and some of the accreting material is ejected along twin opposing jets. While the star finishes its formation, planets build up within the surrounding disk. A few 100 million years later, the new solar system has assembled. Stars and planets form together at billions of sites across our galaxy.
What happens when galaxies collide? With billions of galaxies in our universe, it's no surprise that they sometimes collide. The Milky Way and its nearest similarly sized neighbor, Andromeda or M31, are part of the local group of galaxies. They're pretty close to each other. Only about 10 galaxy links separate the Milky Way and Andromeda. And when they collide in 4 billion years, it will be spectacular. We can simulate the collision of the Milky Way and Andromeda galaxies and predict that it should lead to a great deal of new stars and a whole lot of galactic chaos. Eventually, the two galaxies will merge into a single galaxy, which will settle down into a larger Milkdromeda galaxy. But don't worry, the stars within the galaxies won't collide. Galaxies are made up of mostly empty space, and the stars within them are very spread out. But the gas that surrounds the stars and forms them will collide spectacularly. Many galaxies are in the middle of a collision today. These type of galaxies are the ones that would not have fit into Edwin Hubble's categories. Irregularly shaped spirals, merging and distorting arms winding in strangely beautiful shapes. The exquisite detail of these types of collisions can be studied in a new light with NASA's James Webb Space Telescope.